So this is a voltage source to current source converter circuit, and it is implemented using operational amplifier. This is a very common topology which is taught in the analog electronics course in a third semester or maybe a fourth semester course in electronics engineering or electrical and instrumentation engineering. So let's see the working of this circuit. So this is the input Vs and this is the output, which is our current source IL. And because this is a voltage to current converter, this current source IL will have a Norton equivalent circuit such that the Norton resistance will be equal to infinite ohms. Or in other words, it can be proved that this source IL behaves as a ideal current source. So as before, whenever we are given some op-amp circuit and there are feedbacks present, we try to identify what will be the voltage at either this node or the voltage at the other node, whichever is easier one to calculate. And so because of the concept of virtual short, the voltage at this node, if I call this as Vx, then the voltage at the other node will also be Vx. And judging by this particular topology, it is easier to look at the top branch, and we can easily formulate for this voltage Vx. So let's say that here is a current. Let's say this current is I1. So this current can flow from this voltage source V of S, goes through R1 up to this node Vx, and assuming an ideal diode, an ideal op-amp, which means that the input terminal of the op-amp does not draw any current. So the entire current I1 will flow up until this node V0. And therefore we can formulate the nodal equation as Vs minus of Vx divided by R1 should be equal to Vx minus of V0 divided by R1. And so R1 and R1 can cancel out, and we obtain Vx as the average of the voltage at the two ends across it. So Vx is the average of Vs and V0. And therefore from here we can formulate V0 as 2 times Vx minus of Vs. Now job of this top portion is done. It has allowed us to obtain the value of Vx, and hence for V0 in terms of Vx and Vs. And what we can do is we can now simply look at this branch where we have a positive feedback. And so we can formulate the nodal equation as, let's say this is some current flowing from V0 till this node, and it gets branched into IL, which flows to ground, and then another current which can flow to ground through this resistance R2. So this current can be represented as V0 minus of Vx divided by R2. This current we can call it as IL because we are interested in finding out the expression for this current only. And then the other outgoing current can be formulated as Vx minus of 0 divided by R2. So once we write this particular equation, we obtain an expression where V0 is a parameter, and we have already deduced V0 from the top branch, and therefore V0 is equal to 2 times Vx minus of Vs can be substituted here. And so we go to the next step and we find that this is the corresponding formulation, and from here we obtain Vx minus of Vs divided by R2. This is equal to IL plus Vx by R2, and it is easy to show that this Vx by R2 will cancel out, and you obtain IL as negative of Vs by R2. So this current IL is negative of this source Vs, and it is divided by these resistances, which are mentioned as R2. So the point here is that at a basic level, because we are considering idealization and also we are considering that these two resistances R1 and R1 are same and R2 and R2 are same. But the point to note here is that because this is a voltage source to current source converter, this is your voltage source and it gets divided by a resistance of R2 and with the negation sign. So if we don't consider this negation sign for the moment, we treat only the absolute value, we obtain IL to be directly a function of this voltage source Vs. This negation simply implies that if this voltage source is positive, then the current will flow in the opposite direction. Whereas if this voltage source is negative, then the current will go in this direction. So this is more or less it. There would be, at a higher semester, there could be a lot of modifications to this circuit, considering the fact that all these resistances would have their own tolerances. That means even if we write these to be R1 and R1, in practice you will find that these are never matched resistors. And so there will be some variations. So this could be R1 plus some delta R and this could be R1 minus of delta R or within those tolerance limits. And so it becomes slightly more complicated. The operational amplifier is definitely not an ideal one. And so one can also consider these non-idealities and try to obtain an expression for V0. But overall, in a BTech undergraduate level, it is sufficient to say that with a voltage to current converter, we obtain the current source value, which is the current through the load, which is equal to negative of Vs by R2, and the takeaway point being that this current through the load is independent of the value of the load resistor. So this IL is not dependent on the resistance RL in the circuit. And this is only a function of the parameters which is present and which are independent of the load. So these are dependent on Vs and R2.